Hi, welcome. Welcome to the Western Engineering Satellite Team. I know you guys have most definitely already been chatting with people on the team, whether through meetings or via Slack. This is just a chance for us to kind of all get on the same page, understand what the team does, and what we're planning on doing for the next year and a half or so. Yeah, this presentation will cover all of that and hopefully answer a lot of the questions you have. And then we'll have a chance at the end of this presentation for you guys to ask any questions that we might not have answered through this presentation, as well as ask anything else that you might think is relevant. So yeah, let's get started. So welcome to West. Before we begin, just make sure that you've joined the Google group, which is how you get access to the Google Drive. Make sure you've joined the Slack, which I'm assuming you have if you've managed to make it to this meeting. An important thing though is make sure your notifications are turned on. I've noticed with some people when they set up Slack, it like defaults to some really weird notification settings. So it's like pretty easy to miss things. So definitely take a look on that. Make sure that you're getting notifications on your phone or whatever you use. And then also make sure that you've gotten a message from a team lead, whether it's myself or any of the other execs. If you haven't, then shoot us a message. You can just send me a message right now on Slack if you haven't heard from anyone. I believe we've got everyone covered, but just in case anyone slipped through the cracks, just make sure to hit us up and we'll get you going. Cool. And I'll send out links to the Google group and like how to get set up on that if you don't have access. Just let me know and I can send you those links. Sweet. All right, so let's do a quick overview of how this mission is supposed to work. So essentially in maybe around 2 years time, when we manage to get this satellite off the ground, it'll be orbiting Earth and it'll have a camera on board able to take images of the Earth. So we have two different ways of getting those images down. The first is through amateur radio operators. These are people who have ham radio licenses. They can actually send a command directly to the satellite, given that we've given them permission to do so. They can send a command to take a picture of their current location, and then the satellite will actually downlink that image during that current pass over the amateur radio operator, and they'll get a low resolution image of their current location. So it's kind of like a little selfie thing. On our end though, because we can talk to the satellite over multiple passes, we can downlink that same image or any other images that we want to take through any of our ground stations, which will actually be hosted on Amazon Web Services. They have a whole service for doing ground stations, and we can downlink that image over multiple passes because they're pretty big images, low data rate, that kind of deal. All of this comes together into the Mission Control Center, where we're able to take these images and showcase them to the rest of the community and get people specifically in Western, but also just in the satellite community in general, engaged with aerospace and the things that we're doing. Any questions on how this mission is supposed to work? Awesome. So let's talk a bit about the subteam. So in the top right there, you can see one of the initial prototypes of our satellite. It is a 3U satellite, which means it is 3 distinct units of 10 centimeter by 10 centimeter by 10 centimeter cubes, all stacked vertically. This right now doesn't have any actual subsystems inside of it. Each of those boards would be a subsystem, and right now they're unpopulated, but just to give you an idea of what it looks like. So we'll first jump into ADCS, which is led by Connie and Ethan. I'll give them a quick chance to introduce themselves and talk about what the ADCS subsystem does. So Connie or Ethan, when do you want to take the floor?
Yeah, hey everyone, I'm Connie, one of the leads for ADCS, and Ethan?
Yeah, I'm Ethan, also leading with Connie, leading the ADCS team.
Yeah, so basically our sub-team is responsible for changing the position and the orientation of the satellite in space by determining where the satellite's position is currently. This year, basically, ADCS is just planning to purchase either an entire ADCS system or parts of the system so that we can use these to integrate them with other subsystems that you can see here and within the satellite.
Awesome. Shelby, if you want to talk a bit about communications.
Hey everyone, I'm Shelby. I'm the communications lead. And basically comms is how we talk to the satellite in space. So our objective for the next semester and the year, like the next year as well, is to build a board that is capable of doing the communications with our satellite and communicating with the ground station. So yeah.
Awesome. One thing I should just mention before we keep moving on, you'll notice there's a ton of acronyms. The space industry is horrible for it. There's always a ton of acronyms. They're usually pretty easy to find, but just real quick, if I didn't say it already, ADCS is Attitude Determination and Control System. So it determines where the spacecraft is and then controls it. Comms is pretty easy, thankfully. Our next one is Command and Data Handling, the main processor of the satellite. Sometimes you'll see it referred to as CNDH. Or even just like CDH or CDS, all sorts of wonderful acronyms. But I'll let Jack take over and explain a bit about the subsystem.
Yeah, so I'm Jack. I'm the command and data handling lead. So as a sub-team, we have a few main goals or objectives. The first one is to select components and design the main computer, which is what we call the OBC, or the onboard computer. As a team, it's also our job to connect all the components together with secondary processors. The last goal is to create software that controls and maintains the CubeSat's function using CFS framework that runs on the OBC and the secondary processors. If you're on this team, that's probably what we'll get started on with you guys.
Awesome. Okay, so our next subsystem, the one I already kind of talked about, is structures. We don't currently have a lead for it, but I've been talking to some of the members and just kind of taking that place right now. Essentially, the structure is pretty straightforward. From a high level standpoint, we're creating the structure of the satellite, making sure that it fits within the constraints that it's designed to be in. But there's actually a lot more to it because there's a lot of strict requirements that both NASA and other launch providers have for making sure your satellite, A, doesn't blow up the rocket, but B, doesn't cause a bunch of disturbance in space. So there's all sorts of things like ensuring that your structure doesn't vibrate apart, all the way down to making sure the actual components that are used aren't going to release a bunch of gases into low Earth orbit. So there's a lot of stuff involved in that, as well as thermal analysis and just general analysis that launch providers are interested in seeing. So a lot that goes on there. Cool, we'll jump to our next big acronym here, EPS, or Electrical Power System. This is run by Andrew, who I'll let take the floor now.
Yeah, so EPS is pretty cool. We provide power to everyone else, but we also manage storing it and generating it on the satellite. So a lot of our work so far has been in determining how much power we need and whether we can get it from the solar panels we're going to have and how big a battery we need, things like that. This year, we're going to be focusing a lot on designing the circuit board that's going to deliver all the power and keep it regulated so we don't toast anything on the satellite.
Awesome. And then last up is our generic term for all of the non-technical stuff. This is our operations team. So this is a mix of a few different people. I can't see the call list. I know Alexandra said she couldn't make it, and I'm not sure if Tom was able to make it, but Alexandra's doing a lot of our marketing. So everything on social media, designing the website, those sorts of things. And Tom is helping with finance and some of our events that we'll be running as well. So the two of them make up the majority of that team. If you guys are interested in doing any of the non-technical work on the team, definitely reach out to them. This is from all sorts of things like creating the budget, reaching out to sponsors, finding people within the industry that might be interested in doing a partnership on like social media and have a cool event occur, something like that, all falls under their umbrella. Cool. Okay, any questions about the different sub teams that are on the team, anything they do, anything like that? Awesome. Cool, so our expected timeline, this extends into 2024. Things that are nearer to the future are obviously a bit more rigid, and things as you get further out become just high level goals because we have to actually get to that point in time before we're able to schedule things a bit more concretely. But as a few of the execs mentioned, the ADCS system, command and data handling system, and structures, we're looking to have those COTS components, which are called commercial off the shelf, essentially us finding what's in the industry and either modifying it or just purchasing it exactly as is and finding a way to integrate it. We're looking to have all of those components selected by the end of November. So that means that the majority of our satellites should be fairly rigid in the sense of what components we're using and how they're going to interface with EPS and comms, which their deadline's coming a bit later. since these are getting built in-house, they will be manufacturing their engineering models, which are essentially like versions that are a bit more are less susceptible to breaking. They're not as expensive. They're essentially the ground equivalents of what will eventually go to space. So we're looking to manufacture our first prototypes of those by the end of December so that we can start testing them. And so then same thing happens next semester, where within about 3 months at the start of the semester, so around March, we should have a pretty good understanding of how those COTS components work for ADCS command data and structures. We should have been able to test them properly, done some integration with other components and making sure things are playing well, nicely with each other, and potentially maybe even use some of the engineering models for the EPS and comms to power and communicate with these particular subsystems. But again, it depends on how those EMs for the EPS and comms came through. Immediately following that, we're hoping to have the EPS and comms engineering unit boards tested and completely ready for production, which means all the kinks have been worked out. We have a good understanding of how the system works, and essentially everything's ready to go. In about a year's time, this is when we'll be looking at building the actual fully complete engineering model. So we've started with each subsystem, built up the engineering models for them, got them working, made any revisions we needed to, and now we're ready to build what's called a flat SAT. This will sit flat on a table, hence the name, and let us test all of our software, all of our hardware, all of our procedures on something that isn't real flight hardware, but is pretty damn close. So we'll start building out that entire infrastructure so that we can start getting into some really high fidelity testing. And then the following semester, by the end of that year, we're looking to have the entire flight model of the spacecraft built. This is a section of the campaign called AIT, or Assembly, Integration, and Testing. Again, more acronyms for you guys to get used to. This is like pretty much right at the tail end of you're getting ready to put this thing onto an actual rocket and send it to space. And this is where you would be sending off a lot of your high fidelity models to the rocket manufacturers or the rocket providers. And this is where all of your licensing would be pretty much complete and you're ready to go and transitioning into operations. Cool. Any questions on this expected timeline here? Anything that's not quite clear, anything like that? Awesome. Cool. So here's just some like high level methodologies that we like to have on this team. We do love to design and experiment a lot of stuff in-house. A lot of times in the space industry, you want to buy as much as you can that has already gone to space, put that together, and then you have a very high chance of your spacecraft working. That's not a great methodology for us because we're here to learn. We're here to do things from the ground up. So that does sacrifice a bit of reliability of our spacecraft, but it does mean that we have people that are actively involved in the low-level engineering of how these subsystems are built, how things are made so that they can work in the environment of space, and all sorts of things like that. So it does reduce the reliability of the spacecraft, but it does mean our team has some very capable engineers going into the workforce. That being said, with our industry standards, we always try and follow as many industry standards as we can. These are things that if you went and worked for a space company, aerospace company, even companies that have nothing to do with space will often use a lot of these standards and tools. We want to be using them as much as possible because it's no use if we go and use something like Onshape to build a 3D model, and then you go and graduate and everyone in the industry uses SolidWorks. So we're always going to try our best to use tools that other companies use to give you guys that experience. Now, the very last one is a bit more of a long-term goal. This first mission, we're really just looking to establish the heritage of West so that on subsequent missions, people can kind of see us as a credible place to build satellites. And the hope is that eventually will be similar to other laboratories in the industry where people can come to us with a payload. We work with them, figure out some requirements, and then we build the satellite around their payload. And then we operate it for them and just give them the data that they need. This is very similar to how a ton of other research institutions do this, and a ton of labs that are focused in the aerospace industry. And it gives us a ton of experience, but also helps the research and academic community. Awesome. So that pretty much wraps it up for the high level stuff that I wanted to share about the team. I just wanted to keep it short and sweet, make sure that you guys are all on the same page of what we're doing, what our goals are, and what our timelines are. Now I'm going to open up the floor to you guys. If you have any questions, things that you're unsure about, stuff that you haven't sorted out yet, anything like that, feel free to ask now. Otherwise, we're set to go. Everyone on the same page? All right, good to go. I can't even see anyone. Stupid Zoom. There we go. Awesome. All right, so oh, there's a message in the chat. I always miss that. Thanks, Hannah. Thank you. All right, so moving forward, I want everyone to make sure you stay in really good contact with your team leads. The only way this works is if you're in constant contact, if you're always asking questions, if you're always trying to be involved. We will try and get as many people involved as we can. But again, it's on you. You get as much out of this team as you put in. So if you are just waiting for someone to tell you what to do, that won't always happen. Keep bugging people, keep asking what new and interesting you can do. Keep working towards it, because we're trying our best here as well. But it's also on you guys as well to put the time and effort in. And I promise you, once you graduate, the stuff you learn through design teams such as West will be far more important than any of the courses you do, or any of the knowledge you get from professors. As important as it is to get a degree, a lot of this stuff is stuff that you'll actually be doing in the industry. So definitely take advantage of it while you can. Awesome. With that said, we'll wrap it up. I'll post this recording in case anyone missed it, or anyone wants to go back on it. Other than that, I hope to see you guys at meetings. I'm entirely remote because I'm on the other side of the continent, but if I can make it to meetings, I will try my best. So I hope to see you guys at that one, but enjoy in-person meetings and doing stuff on campus. Awesome. All right, I will see you guys when I see you guys. Bye.